All right, let's dive into our review of day 5 of the Google Kaggle Agentic AI intensive course. Today is all about AgentOps. We're going to tackle that absolutely crucial journey of taking a cool agent prototype and turning it into a real production-ready system that you can actually trust. So let's get into it. And this quote from the course really just hits the nail on the head, doesn't it? Anyone can spin up a quick demo that looks impressive, but making it something you can rely on, something you can trust with real tasks, well, that's a whole different ballgame. That's the real challenge. So just how much work are we talking about here? Get this, a staggering 80% of the effort that goes into making an AI agent has nothing to do with the core AI model itself. Nope. It's all spent on the surrounding infrastructure, the security, and the nonstop validation you need to make it dependable. That one number, it totally changes how you have to think about building these systems. And that 80%, well, that's what creates what people call the last mile production gap. The course material describes it perfectly, though. It's not just a final step, not a last mile at all. It feels more like you're staring across a massive, gaping canyon that separates your cool demo from a product that's actually ready for the real world. So how in the world do we cross that canyon? We build a bridge, and that bridge is called AgentOps. First up, we're going to lay down the human foundation. Then we'll build the automated highway to production, figure out how to manage the agent once it's live, and even see what happens when agents team up. And stick around because at the end, we'll talk about the real prize for doing all this. Okay, first things first. Before we write a single line of automation code, we've got to talk about people and process. You could have the fanciest tech in the world, but it's pretty much useless without the right team and the right rules to govern it. It's the people working together that really prevents things from going off the rails. And that team structure, it's evolving. It's not just the traditional MLOps roles anymore. We're seeing these new, super specialized roles pop up. You've got prompt engineers who are this amazing mix of tech-savvy and domain expert. They're the ones who define the agent's core rules, its constitution. Then you have the AI engineers who take that blueprint and build the heavy-duty, scalable systems to make it all work reliably. All right, now let's get to the tech. The absolute heart of AgentOps is creating an automated path to production that is guarded by evaluations at every step. The best way to think about it is like a gauntlet. Every single change, every update has to run through this gauntlet, and it's brutally tested to make sure only the absolute best, safest versions ever make it to your users. And this brings us to the most important principle of the whole thing: evaluation-gated deployment. It's a simple idea, really. No new version of your agent gets to interact with a real user until it has automatically passed a whole battery of tests that prove it works, it's safe, and it's following the rules. This is how you move from just hoping for the best to having automated confidence. So what does this path actually look like? Well, picture it as a funnel that gets progressively stricter, designed to catch errors as early as possible. First, before any code is even merged, you run a bunch of fast checks. If it passes that, it moves on to a staging area for the heavy-duty tests. Load testing, and even dog fooding, which is where your own team uses the product to find bugs. Only if it survives all of that does it get promoted for a final, gated deployment that, usually needs a human to give the final thumbs up. But even after all that, you don't just flip a switch and release it to everybody. No way. Safe rollout strategies are your final safety net. You might do a canary release to just 1% of your users, like the canary in a coal mine. Or you could use a blue-green deployment, where you have 2 identical environments ready so you can switch back in an instant if anything goes wrong. It's all about minimizing risk. Now let's switch gears and talk security, because this is huge. The course highlights Google's 3-layer approach, which is really smart. Layer 1 is the agent's constitution. This is where you write down its fundamental rules, its boundaries, right there in its system instructions. It's the core of its identity. Of course, a constitution is just words if you don't enforce it. So that's Layer 2, enforcement. This is where the rules get some teeth. We're talking hard stops for forbidden actions, filtering out bad stuff coming in and out, and for really risky moves, escalating it to a human in the loop to get approval. And finally, there's Layer 3, continuous assurance. Security is never a one-and-done kind of deal. It's a process. It requires constant safety checks and, importantly, proactive red teaming. That's where you literally have a team trying to break your system, trying to find holes so you can patch them before the bad guys do. Okay, so we've built it, we've secured it, we've deployed it. Phew. But our job is not over. Not even close. Now the agent is out there, in the wild, and we have to manage it. It's not a deploy and forget situation. It's a continuous living cycle. And that management happens in a simple 3-part loop. First, you observe. You have to understand what the agent is doing and, just as importantly, why. Based on what you see, you act to keep everything running smoothly. Performance, cost, safety. And finally, you use all that data and learning to evolve the agent, to make it smarter and better over time. To really observe properly, you need what they call the 3 pillars of observability. You have logs, which are like the agent's diary, a detailed record of every single thing that happened. Then you have traces, which connect those log entries into a story, showing you the why behind an action. And finally, you have metrics, which are like the high-level report card on the whole system's health. And when you do spot a security threat, you need a playbook. You can't be making it up as you go. The plan is simple. Step 1, contain the problem immediately with something like an automated circuit breaker. Step 2, triage the issue. Get some human eyeballs on it to understand how bad it is. And step 3, resolve it by pushing a permanent fix through that same CI/CD pipeline we already built. So, everything we've talked about so far has focused on a single agent, but the real power, the real future, is when you have lots of specialized agents all collaborating. The trick, of course, is getting them to talk to each other and work together effectively, which means we need some common rules, some interoperability protocols. The course points out 2 key protocols for this. There's MCP, the Model Context Protocol, which is for simple, stateless interactions between an agent and a tool. Think of it as telling a tool, do this one specific thing. Then there's A2A, or agent to agent. This one's for much more complex, goal-oriented collaboration between 2 intelligent agents. It's like saying, here's a big goal, go figure out how to achieve it. And to really make this clear, the course uses a brilliant auto repair shop analogy. It makes it all just click. So picture this. A customer uses A2A to tell the shop manager agent their goal, like, my car's making a weird noise. The manager then uses A2A again to delegate that complex job to a specialized mechanic agent, but then that mechanic agent uses MCP to talk to its specific tools, like telling a diagnostic scanner to run a scan. See? High-level goals use A2A, low-level actions use MCP. So that brings us to the grand finale. We've built this whole AgentOps bridge, right? With people, automation, security, and operations. But why? Why go through all that trouble? It turns out stability and security, as important as they are, aren't actually the ultimate prize. Here it is, the crucial point. The ultimate prize of AgentOps is velocity. It's the ability to safely ship meaningful improvements, new features, and critical fixes in a matter of hours or days, not weeks or months. It is the engine that lets you evolve at lightning speed, and that is the real competitive advantage. And this all leaves us with one final massive question to think about. We've laid out a solid plan for one agent or maybe a few agents working together, but as we start building these huge ecosystems with thousands, maybe millions of agents all collaborating autonomously, how are we going to govern them? How do we scale these ideas to ensure that future is safe and effective? That's the next great challenge.